Let's talk about TDD. Do you know what TDD stands for? Correct. Test-driven development. And what that means, right?
What it means, so just from the very first principles, considering testing, scripting outcome. So sometimes you write tests first, and then you do some work.
Yeah, correct. So TDD is a strategy towards coding. It's a pattern. It's very important in the industry. For some people, this is like a philosophy. It's a way of living. Well, that's maybe too much, right? But still, it's very important. It's why? Because in theory, well, not in theory. I mean, this has been proved several times over time. So it clearly helps to write maintainable code, right? So TDD, in the way it works is you think on the functionality, so you create a test for that functionality before the functionality even exists. And then, once you have that test that proves the functionality, you create a functionality to satisfy the test. Generally speaking, in classic industries, it works on the other way around, right? So, for example, if I'm creating this remote control, which I broke a couple of times already over the weekend, don't ask me why. So first of all, I build it, and then I test that if I throw it against the floor, it doesn't break, right? You build it, and then you test it. But with TDD, it's on the other way around. You test something that doesn't exist yet, and then you build that, right? So it's a bit mind-blowing. And especially at the beginning, and for some people not even at the beginning, it's very complicated to adopt. Because you never done something like that in your real life, right? That's why what the gurus, what the experts said is, at the beginning, do TDD even if you don't think that's the right thing to do. Just do it. Just do it, because it's just a matter of time that you convince yourself that's the right thing to do, right? So this is what I'm going to do now. Even though you didn't know, you've been doing a kind of TDD from the 1st of November. Why? Because a coding challenge is TDD. A coding challenge is a test that someone, me speaking, has written, and then it's your task to create a functionality to satisfy the test. This is TDD, right? You do the test first, right? Expect welcome to JavaScript to return welcome to JavaScript string. That's a test. So then you have to create a function that returns welcome to JavaScript. Does it make sense? Cool. So let's see how to run tests. That's the first thing. Historically speaking, that's been a bit painful, but fortunately in 2018, thanks to Create React App, it's very easy. So the only thing you need to do to start working with tests is open a terminal and then type npm run test. Correct. So if you just type that, something will happen, right? No test found. That's interesting. No test found. No, are you sure? No test found. Oh, right. So there are two options here. There are some options here, right? So this is an interactive menu. So in the first time you run it, probably you'll get some results because I'm running this morning already, I need to press A to run all the tests. Let's try now. Correct. So this is likely to be your very first screen. Look, this is telling A, pass. One test pass. I haven't written any test. What's that? This is because with Create React App, it comes with one test, which is cool. That's nice, because at least you can get a feeling about how to write a test. To me, that's a weird test, because every time you do a test, you expect something, right? If I throw the remote control against the floor, I expect not to break it. That's why I expect. This test doesn't expect anything, right? Which is weird. But anyway, we'll create a proper test now. So, what I'm going to do is I'm going to create a function. I'm going to create a function called who am I. And that function will receive some questions and depending on the question, it will answer different things, right? Have you ever played Who Am I? Maybe, right? Who knows? So, I'll create, first of all, the test, right? I'm going to add the .test suffix. With the .test suffix, then React, well, this is not React, by the way, I didn't mention about which technologies are involved here. So this is mainly using Jest. So Jest is a testing framework that is related to React, so you can test React components, but under the hood, Jest integrates some utilities to test vanilla JavaScript. So I have the test, so I create the file whoami.javascript, and then this is the way I've been doing testing for all my life. I put the test on the left and I put the source code on the right. This is absolutely personal, but the reason why I love it is because if I do TDD, generally speaking, you start reading the screen from left to right? So I do the test first, and then I'll modify the functionality to satisfy the test. Then I'll add a new test, and then I'll go to the right? It's like a ping pong game. So I'm even going to remove the sample test because this doesn't give me any value. So I'll remove the sample test. And now, let's create the test. So to create the test, the very minimum thing we need to do is to type that. Oh, wait a minute. That's wrong. That's weird, right? So we need to type IT. And then with IT, you specify the test, the name of the test. So the name of the test, for now, just testing this works. So then let's check the expectations. You remember on the app.test, I missed an expectation. So let's add an expectation, which means expect true to be true. This obviously works, because if I expect true to be true, that returns true. So the test passes. And you can see that you get the summary of the tests that have run. Yes, testing this works in that file. It took 1 millisecond, right? All good. What happens if I change true to false here? Hopefully, right? Correct. Expect true to be false. That's obviously not correct. So then you get red text at the bottom, right? And then it's telling you this is really good. It tells you what it expected and what we actually return. So this is the most fundamental thing about testing. You put IT and then you expect something. In modern testing, you can also type test if you prefer, which is the same. It's probably a bit more human friendly, right? Because this is a test. And one more thing, generally speaking, we encapsulate tests with blocks. So what is a block? You can type describe. So describe is another special function in testing. So when you put describe, you can put multiple tests inside of it. Right? So this is just to encapsulate several related functionality, right? So look at the console. You see? So this is like the heading. This is a block, and then just testing this works. So obviously we can have multiple tests. You see? So for that block, blah 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 blah, right? And then you get the summary. So this is the classic structure of testing. Describe block, and inside of it either test or IT, right? It's worth to mention that, for example, if we know that the first test works, but we don't know why the second test fails, right? I mean, this example is trivial. We have 2 tests, but real products may have thousands of tests. So you don't want to run all the tests every time you change a single one. Because of that, you can, I think the syntax, I'm not sure, I think it's FIT, correct. So if you put an F in front of your test, look, it will literally just run that test, ignoring everything else. So for performance and focus reasons, that's a good thing to do. However, this strategy is scary. Does anyone know why? We shouldn't ideally do that ever. That happened to me several times. Correct. So that has happened to most of the developers. So you are working with a piece of functionality and you do that, right? Because you want to focus on one problem, and then you realize how stupid you are because false cannot be true. So then you fix it, and then it works. So then you say, okay, brilliant, commit and push, right? What's the problem? We are just running one test. So if by changing that piece of functionality I broke something else, I didn't notice. I won't notice because all the other tests will be ignored. That's why this strategy is a bit dangerous. Of course, we could have some rules, some pre-commit hooks to detect these kind of things. So if you try to commit something with FIT or something like that, then we could block the commit. Right? So we can still handle that. Or we can run one single test from the command line, or I think now with this interactive, you see, we can even filter the test we want to run from the command line. So modern testing has different strategies towards minimizing the impact of running a single test. Anyway, any questions so far? No? Cool. So let's write a proper test. As I said before, the first thing I want to do is I'm going to create, let's rename that. So, who am I game, or function if you want to be a bit more strict. So returns wrong if no question is provided, is offered. So what I want to do is I want to call the who am I function without any question, and that should return wrong. The test fails, obviously. Why the test fails? Well, reference error, who am I is not defined. That's TDD. TDD is about failing all the time. And once something fails, then you fix it, and once you get the green build, then you do a new test and you make it fail, and so on, right? So let's create a function, who am I. By default, the only thing we know, even though if in our mind we know what we want to build, we shouldn't build anything here apart from what the test expects. So the test expects to return wrong, so just return it. Why it doesn't work yet? Correct. We are not exporting the function, right? And we are not importing it neither. Look, it works. That's good, right? So now our function returns what we want based on that very simple aspect. So let's add another test. So the next test we'll say returns yes if the question is am I part of a, let me break it in another line. Am I part of a variable declaration? So, if that's the question, I expect my function to return yes. It again fails, right? But it fails because we need to map that functionality, no problem at all. So let's have the answer here. No, sorry, that's the question. So let's use the ternary operator. So if we said question equals, am I part of a variable declaration? Then we'll return yes, otherwise we'll return wrong. Right. Right, this is wrong. We cannot have an empty line after the return statement. So if we change it, now it works. Does it make sense? Any question? Yeah, that's the same. So Jest runs on top of Jasmine. So Jest uses Jasmine. So it's the same syntax, because in reality Jest uses the Jasmine syntax. So Jasmine, same as Mocha, so they are two test runners for JavaScript. So then Jest integrates them and adds more functionality to test React components. Yes, correct. So, next question. So, because Tom already knows the answer, he wants to solve the game, right? So, returns wrong but close if the question is am I null? So if that's the if the player says that he's null, we want to say no, you are not null, right? So how can we do that? We can say expect who am I null to be wrong but close. So then we need another ternary operator here, right? So we can say question equals am I null, then wrong but close. Sorry, that's wrong, right? So it goes here. I mean, if you find the ternary operator a bit too much for this example, you can probably use just nested if else, right? Right, and that is, what is that, Tom? We need a colon. A comma.
You look at the
Oh, right, correct. You see? Cool, thank you, Tom. Cheers. And then it works, right? So you can see that we can add multiple assertions, right? Multiple statements. So let's finish the game here. So it returns yes, you won if the question is am I undefined. Makes sense, right? So then we can simply, we'll just copy paste it. Am I undefined to be yes, comma, you won. It fails because obviously that functionality is not declared yet. So at the moment it returns wrong. So we can again change the ternary operator, which is too complex already, right? Right, so then it works. So remember, you create one test, then it fails, then you fix the failure. Once everything is green, you create a new test, then it fails, blah, blah, blah. It's the same pattern again, again, again. Any question? So these are the basics of testing. I found this particular spec a bit complex. Why? Because in reality, look at the pattern. The pattern is always the same, right? We always call a function with an argument, if any, and then we expect to get something back. Function with an argument, something back. The pattern is the same. All the tests have the same structure. Whenever that happens, and this is common, this is super typical, right? For example, if you create a function to validate an email, you will invoke the function several times with different emails, valid emails, invalid emails. It will return true or false depending on whether the email is valid. For this kind of basic input-output functions, I recommend you to unroll the spec. Do you know what unrolling a spec is? What's that, Tom?
So you've got like a similar structure for each of those tests.
Yep.
What you do is you put it in an array, and then you loop over that array, changing it to everything that's changing in each test.
Correct. That's correct. Let's do that. Let's do that. So we can simply create an array of tests. And for each test, we'll have the expectation, not the expectation, we have the title of the test, then the question, and the answer. So then for each test on the array, this is a scenario. You can call it test. That's how you want. I've been calling a scenario for all my life. I don't know why, but yeah, it's relatively common to call it a scenario. So we can simply put the test here, and then you tell me what do we need to change here to make it dynamic according to the array objects. Here, what we put here? Like that? Wrong. What's it? Correct. Thank you, Marta. It's about basic JavaScript, right? We have an array, of objects. So for each object, which is the scenario, you can access any property, right? What do we put here in the argument? Dot what? Correct. And here? Easy, right? Because the test is the same. We just need to play around with different values here. So now it's much easier because instead of playing with a list of tests, we play with a list of objects. So I'm simply now just copying the different values. So when the question is, am I part of a variable declaration? The answer will be yes. And when, let's unroll it again. So when the question is, am I nil? It returns that. Am I nil? Wrong but close. And finally, when we pass am I undefined, it returns yes, you won. So we can get rid of that. So as you can see, now we have a single test that is executed multiple times, which depending on the question, it gives a different answer. This to me is easier to follow and to understand, right? Question that, answer that. Question that is more compact. So I can get a better understanding about what the functionality is doing. Testing has mainly two goals. First of all is ensure the quality of the product you are building. Because if a friend of mine changes the code, at least one test will fail, so he'll ask himself whether this is a good thing or not to change, right? So it's a good way to protect us against possible changes. That's the first reason. The second reason, which is not that obvious, is it serves as to document your code. So if I read that piece of code, I may struggle a bit to understand what the logic is, right? Lots of nested if-else statement. But if I read the test, I'll get a better feeling about the purpose of the function, right? So coding, testing is not just about protecting against problems. It's also about documenting your logic. Right, so it fails. It fails, right, because I did that on purpose, to be honest, but then you can see easily that at some point you expect yes, but we are passing yes with exclamation mark, right? So then we can find what it is, we can fix it, and then all the tests pass. Any question? Two more things. First of all, this is TDD. TDD, test-driven development. You invoke a function with an argument, it returns something. Maybe you heard about BDD. What's BDD? Behavior-driven development, correct. So BDD is very related to TDD, but it's about being a bit less technical and a bit more human-oriented. This is purely technical, right? Function, argument, function input output, function input output. But then there is a way to improve the readability of the test using the AAA pattern. Do you know what the AAA pattern is? Nice one. Do you watch the other video we recorded? Cool. Nice one, Tom. So yes, correct. We can do that. Arrange, act, assert. We're going literally to do the same thing, but just for readability purposes, we're going to refactor the test a bit. So arrange, act, assert. That means prepare the test, then do something, and then expect something to happen. Arrange, act, assert. I personally prefer given, when, and then. Correct. But just a matter of styles. Also, you can see I'm using commands. There are some frameworks, some utilities to do that using a function called given. I don't think it's supported here. Let me try. Oh, thank you. Probably not, right? That's not even supported. But there are some plugins that you can use them. You can use that as a function to be a bit more explicit. But hey, I like to keep things simple. So, given, let's prepare the test. So to prepare the test, I'm going to create generally speaking, on the given or on the arrange, we create variables. So question equals scenario.question. So when what? When I call the function, then I expect answer to be scenario.answer. You see? It's literally the same test, but we've split it into 3 steps. You could argue that this is a bit noisy, that we don't need to do that. And for this particular example, I may agree, because it's so trivial that, But in reality, tests could be a bit more complicated than that. So because of that, even though it's a bit unnecessary and a bit over-engineered, I'll recommend you in the long term to stick to that pattern, because for more complex tests, it will massively help to understand what's going on.
Is it always the same structure, or you can add like extra bits?
Well, you can add whatever you want. This is a command, right? So I can put here gim instead of given, right? It will.
But like the logic, like if I have a question to answer, then.
Yeah, correct. So.
Or is there like any extra?
No, generally speaking, it's just 3 steps, given, when, then. On the given, you prepare your variables. Yeah, when you invoke the function, you save the result, and on then, you simply evaluate the result, right? That's generally speaking sometimes some people does at the end clean up if they want to do something, I don't know. But generally speaking, given, when, then will work in 95% of the cases. Correct. Yeah, that's a good point. You can. Yeah, you could call another function here, expect true to be, well, this is a fake example, right? But you can do that. You can have multiple expectations in one single test. In the long term, I'll recommend you not to do that. So if you need to do that, create a new test. So try to keep the test, the shorter, the better. This is a classic problem. Some projects stop testing because of the complexity of testing, right? That could grow. You could have a 50-line test, and we should avoid that, because the more complex the test is, the harder to maintain it will be. And now we are dealing with the test. So now if something goes wrong, the logic is very fresh in our mind. But if that test fails in 6 months' time, or even worse, if we change something and we broke a test that a colleague who is probably not even working in the company anymore wrote 2 years ago, it's like, really? I don't want to fix that. So to minimize the impact of struggling with tests, keep them dry, short, precise. Also, something I would recommend you to do, because I've seen lots of senior developers that they do the same thing, and I think it's wrong. Generally speaking, people start a test doing that. Should return, should set, should get, should, I hate it. Don't do that. If you are writing a test, you need bold statements. If you say should return, like, yeah, ideally, in a perfect world, no, wrong, returns, right? Returns, bold, strict. We are 100% sure that will be the answer, right? Well, don't put it in bold, right? In capital, right? You know. Some people said must return. I like must return, right? But just for simplicity reasons, my suggestion is just returns. Cool. Any question? No? So 2 more things. I didn't prepare that, but yeah, I hope it works. So when you are writing a test, generally speaking, you can do that, right? So you can compare Tom to be Tom. Right. Yeah, Tom to be Tom, and it works, right? This is it's not related to what we've talked so far. But what happens if we compare arrays? Look, that's a bit exotic, right? Expect array Tom to be array Tom. Wrong. Wrong. Interestingly, I mean, when I was young, we didn't get this kind of help, right? So it was a bit harder to fix. But now, it's the first time I see that, to be honest. It's telling you that if you want to compare complex data types, like arrays, like objects, all these things, you cannot use to be. So to be is very useful to compare string versus string, number versus number, Boolean versus Boolean, but not with arrays. So to fix it, as Tom already suggested, you have to type to equal. And then it works. So if I change the value, it should fail.
Is to equal used on arrays?
To equal, that's a good question. Look, so you can use to equal all the time, because to equal also works with basic data types.
If you want to be on the safe side, you can do
That's a good question. That's a good question. Should we use to equal all the time? What do you think?
No.
Why not? In? What? That's correct. Yes, you are right. You're right. This is a classic job interview. If you join Sky, they will ask you that. So they will ask you, what's the difference between to be and to equal? You know that already. And then they may ask you, which one do you prefer and why? Right? So some people they argue. And again, nothing is black or white, right? So you could defend that theory. You could say, hey, to equal, so to be just works with basic types. To equal works with basic and complex. So for simplicity reasons, let's use to equal, and you know, easy, right? But that's, even though that's an argument, and I partially respect that argument, that works fine here because we have one test. If you have 5,000 tests, please know that to equal is less performant than to be. Because to equal is more complex. It's checking the type, it's checking, deep comparison, it's doing more things, right? So it's more complex. So to me, it's valid, it's necessary to use to equal when you test complex things. But if you are testing something simple for performance, for efficiency reasons, please stick to be. Any question? No? So the very last thing I would like to show you is something called Istanbul. This is probably my favorite tool, my favorite tool ever. So in a real life, yes, you'll be doing some testing and you may create a pull request like you, Tom, and Osman did last week, which is really good. That's really, really good. But eventually, who is controlling your coverage? So who is controlling that this function is tested or not? And if it's tested, that every single line is tested. Yes, of course. You can spend 20 minutes of your life looking at every single spec and see, you know. But in real life, that doesn't scale, right? That doesn't scale. Thankfully, we got Istanbul. So Istanbul is a very sexy tool that tells you the test coverage for each file. So this is really, really, really good. Why? Because, for example, I can see that someone created a file called object filters, but the function coverage is just 67%. So that means that some lines in that file are not actually tested. And even further, and I love that, you can see it has a reporting tool, so you can see which lines are tested and which lines are not tested. Right? There are some very nice online examples. Not sure if I find one. Istanbul testing online demo. Yeah, maybe not, but I'm sure if we spend some minutes eventually, you see. So this is the type of reporting that I mentioned. So you can see for each file in your component tree, right? It's very easy to spot where the potential issues are, because if a file doesn't come with proper test coverage, if there is a bug on that file, no one will notice, right? And this is what I also love. We can integrate Istanbul with a continuous integration tool. So for example, we can create a rule that whenever you commit and push, if the coverage is below a given threshold, like 80%, then the push gets rejected. Right? So we can industrialize that quite a lot. Yep. So unfortunately, it's not that common to have Istanbul installed in companies, but if you join a small project, it could be a good opportunity to start working with it. Right? Any question? No? Cool. That was it, guys. Thank you.